Hang on, it's about to start. Today, we're going to travel to the farthest reaches of the vast expanse. Years ago, astronomers aimed the Hubble Space Telescope at a tiny dark region of the sky. To the naked eye, it appears as small as a pinhead at arm's length. This region shows a minuscule fraction of the sky depicted here, adjacent to the Moon. And it would take 23 million photos like this one to cover the entire celestial vault. Yet, after 1 million seconds of exposure time, the scientists obtained this, one of the most extraordinary photos ever captured. A small number of these bright points are nearby stars, which are in the foreground. But the rest, all the rest, is just galaxy. In this single snapshot, by finally analyzing all the data, we were able to identify nearly 10,000. As grand and unsettling as this image may be, it can give the impression that space is filled with objects relatively close to each other. How far away is all this really from us? Far, obviously, but how far? To answer this question, we will have to undertake a journey to the edges of the known world, to the abyssal depths of gigantic space.
Let's take an infinitely average human being like me who is 1 meter 80 tall. I am 65 times smaller than the tallest tree in the world. He is 7 times smaller than the tallest skyscraper and about 10 times smaller than the Himalayas peak, whose bulges are invisible from space. Earth is immense in comparison, but with its roughly 12,435 miles diameter, you'd need 10 Earths to equal Jupiter's diameter and 10 Jupiters for our suns. This image shows our solar system's planets with accurate size scales, but not distances. Earth should be 196 feet from the Sun here, and Jupiter 328 yards. Scary, astonishing,
disturbing. Our star is positively huge. At the speed of an airliner, it would take nearly 6 months to go around it. And yet, it is so small compared to others. Here is our Sun to scale, compared to the stars Gamma Orionis and Algol B. And these 3 stars compared to Rigel and Aldebaran. The transparent sphere here corresponds to a distance of 1 light minute. The distance traveled by the fastest thing in the universe in 1 minute. And all these stars would fit without problem in the star Doradus, itself ridiculous in view of the size of the supergiant Betelgeuse, represented here in brown, and which could easily encompass the orbits of Mercury, Venus, Earth, Mars, and almost those of Jupiter. This little point in the center is our Sun. To go from here to there, to cover the distance that separates our star from the Earth's orbit, the light that moves at the prodigious speed of 300,000 kilometers per second takes 8 minutes. At a commercial airplane speed, it would take 17 years. And all these distances
are contained in this small square. In this scale image, Earth's orbit is barely visible. The Voyager 1 probe, which left in 1977, 10 years before I was born, and which is the man-made object furthest from Earth, is currently only here. This probe is nevertheless hurtling through space at some 61,000 kilometers per hour, 160 times faster than a Formula One car. In 40 years, it has covered a prodigious distance, equivalent to 2,000 years of non-stop travel at the speed of a commercial airliner. But as mind-boggling as its speed may be, it is only here. Although it is now 140 times further from the Sun than we are, it has not even covered the equivalent of 1 light day.
And everything we just talked about fits into this little square. Voyager 1 is somewhere over there, and the Earth's orbit at this scale is not even visible anymore. The red ellipse in this image represents Sedna's path around the Sun. Sedna, a round one, 0 miles in size, is among the farthest known trans-Neptunian objects. And I feel smaller and smaller, because all of this is in that little square. Sedna's orbit is absurd compared to the vast size of the Oort cloud. It contains billions of comets orbiting around our star. The edges of this ice cloud are so far away from us that Voyager 1, speeding at 1 million kilometers per day, would take 1,200 years to reach it. The distance is 50,000 times that from Earth to the Sun. And it's impossible on this image to represent the edges of the cloud. It's estimated to take 12,000 years for the probe to exit and reach the gravitational boundary of our system. And even so, Voyager will have only traveled a distance equivalent to a quarter of that which separates us from the nearest star to us. Let's continue, let's zoom out.
Here are our Sun and its nearest neighbors. The yellow ball here is not our star, but its estimated maximum gravitational sphere of influence. The largest circle represents 10 light-years. It includes Sirius, which is 8.5 light-years away, and Betelgeuse at a similar distance, and here the Proxima and Alpha Centauri system. In this poignant void, the stars are not to scale, as their size would then be less than a pixel. The distances between stars are incredibly vast. When discussing close neighbors, we must use close neighbors very carefully. To cover the gap of 4.2 light-years that separates us from the closest system, even at the phenomenal speed of 17 kilometers per second that Voyager travels, it would take 80,000 years.
To try to represent the colossal void that separates us from Proxima, and respecting the scales of size and distance, imagine the Sun in the form of a basketball located in Paris. Proxima Centauri, a smaller star than our Sun, would be the size of a ping-pong ball located in Istanbul, Turkey. The most disturbing revelation is that Proxima becomes our neighboring star when examining a map of stars within a 30 light-year radius. And everything we've seen previously fits into this region. And all of this is nothing compared to the enormous size of our galaxy. All the stars located within 30 light-years of us become a ridiculous point that we struggle to distinguish. In the middle of this tiny circle, that alone has a diameter of 1,000 light-years. And about a third of the stars visible to the naked eye are located in a region 4 times smaller than this one.
Put back in our place, we are here. Think about it the next time you look up at the night sky. Because even under the best viewing conditions, almost all of the 10,000 stars visible to the naked eye fit into this region. In fact, no one has ever observed our galaxy as a whole because we only see a slice of it. We are inside it. We would need to be able to get out of it. Count 550 million years at the speed of Voyager 1 to be able to reach a point far enough off-center to take a full picture of it. This monster spans 100,000 light-years from end to end, with a thickness of 1,500 light-years. If all Earthlings shed the stars that the Milky Way contains, we would each have about 40.
And if we reduced our Sun to the size of a white blood cell, the Milky Way would be as big as Europe. Vertigo of the void. Here lies an astronomical number of huge objects. This is the Helix Nebula, this magnificent nebula, and what remains of a star that has expelled its outer layers of gas. Let's pause for a moment in front of this image to take in its enormity. The Helix Nebula could fill the space that separates us from Proxima. And these droplet shapes that we observe when zooming in, each filament is approximately the size of our solar system. Yet, as poignant and immense as it is, a nebula of this type is nothing more than a small dot among billions on the scale of a photo like this one. Vertigo to the cosmos.
Let's zoom out again to place ourselves on the scale of our local cluster, which includes our galaxy, the Andromeda 1, and a procession of about 50 others of smaller size. The width of this image is 4 million light-years. The sizes and distances are roughly to scale. The space between galaxies is mostly empty. Here, 2.36 million light-years separate our galaxy from that of Andromeda. If we could place them one in front of the other, the Milky Way would appear strangely small to us, because Andromeda is twice as large and contains nearly 3 times as many stars as ours.
The whole of this group is itself agglomerated into an even larger supercluster, whose staggering size is estimated at 150 million light-years. In this Virgo supercluster, there are about 10,000 galaxies, distributed in 100 clusters. We find ours here, and that of Virgo, distant by nearly 60 million light-years. Stellar void, always more astounding.
Among these thousands of giants is M87, a galaxy that would make ours and Andromeda's look like sketches of gigantism. Because M87 is 10 times wider and 200 times more massive than our Milky Way. A titan that yet seems insignificant when scaled against the colossal Hercules galaxy. Itself a clay-footed colossus compared to the immeasurable icy 1011, which in the incredible bestiary of galaxies remains to this day the largest in the known universe, and which houses over 100 trillion stars and whose mass is 2,000 times greater than that of our Milky Way. Icy 1011, as enormous as it is nothing more than a small dot on this image where each white spot represents at least one, if not several galaxies. Space certainly lives up to its name. And we are struck by the amount of dark areas that are there to remind us with their inky blackness, just how vast and empty the universe is.
Let's move further away to embrace an ever larger scale, to peer into the abyss in the depths of the unspeakable. We are now at the level of the local supercluster, which groups together all nearby galaxy superclusters. Everything we've seen before fits in there. Each set represented here can agglomerate tens of thousands and thousands of galaxies of incredibly varied shapes and sizes.
One region where the immense is more than worth mentioning, but pales in comparison to the vastness. Because our local supercluster is nothing more than a small point in the center of our observable universe. The number of such superclusters is estimated to be something like 10 million, everywhere you look, no matter the direction of the superclusters, over and over again.
And we would almost plunge towards infinity. But beyond the edges of this image, the deafening geography of the known universe stops. The entire universe, however, continues, perhaps beyond anything the imagination is capable of conceiving. It's not that we are facing an insurmountable border, but this is the limit of the universe accessible to our view. A sphere with a radius of 45 billion light-years that includes all objects whose light has had time to reach us. Beyond this horizon, the edges of the cosmos, there are certainly other superclusters of galaxies, billions upon billions of stars, planets, and emptiness.
Thinking about all this, we are filled with paradoxical emotions. Chills felt when facing something that exceeds us. I feel ridiculous, insignificant, but alive, and therefore extraordinary.
Precious. Much too small is not a number. What matters most cannot be counted. Let's worry about the essentials. With that, I'll leave you and try to find my place in this vast world. There's no such thing as 3 times nothing. 3 times 0 is something. Help us make this our profession.